When the moon is no longer the land of dreams. Just a few decades ago, the moon was still a symbol of humanity's ambition to reach beyond Earth. The Apollo 11 mission, which brought Neil Armstrong and Buzz Aldrin to set foot on the lunar surface in 1969, was hailed as one small step for a man, one giant leap for mankind. Yet, after that moment of glory, the moon seemed to fade from the forefront of exploration priorities. Major powers shifted their resources toward other goals, such as the International Space Station ISS, robotic missions to Mars, and astronomical research in distant orbits. Entering the 2020s, however, the moon has made a striking comeback on the strategic space map. No longer just a technological milestone, lunar conquest is now tied to ambitions of resource extraction, such as helium-3, polar ice deposits, and rare minerals. Plans for long-term settlements are also being developed, positioning the moon as a stepping stone for journeys to Mars and beyond. This new space race is no longer a simple rivalry between two superpowers. It has become a truly international arena, with participation from the United States, China, Russia, Japan, India, and even private companies. Against this backdrop, three recent headlines: China's test of the crewed lunar lander Lanyue, NASA's plan to deploy a nuclear reactor on the moon, and the LunaRecycle competition for in situ material recycling, vividly illustrate the renewed ambition to conquer the moon. They also reveal the intense competition in technology, innovation, and strategic interests among nations. Together, these developments paint a comprehensive picture in which science, economics, and politics intertwine, transforming the moon from a land of dreams into a new frontier of the 21st century. 1. China's bold leap with the Lanyue lander. On August 7, 2025, the China National Space Administration, CNSA, officially announced the successful test of its Lanyue lander, meaning embracing the moon. This vehicle is purpose-built for China's ambitious goal of landing Chinese astronauts on the moon before 2030, a milestone aimed at solidifying the nation's standing in the modern space race. The test was conducted at a special site in Hebei Province, designed to replicate the moon's harsh terrain, complete with thick layers of fine dust, impact craters of varying depths and sizes, and rugged rocky surfaces. The objective was to assess the lander's precision landing capabilities, the stability of its landing legs, and its gravity balance system under simulated low-atmosphere conditions. What sets Lanyue apart is its fully integrated design. It is not just a simple lunar lander, but a mini-station equipped with living quarters, a control area, a hybrid solar power generation and storage system, and a small data center to support communication and mission coordination. This approach ensures that astronauts can work and live on the moon's surface for several days, or even weeks, rather than the brief touch-and-go visits of the Apollo era. This strategy aligns closely with China's plan to build the International Lunar Research Station, ILRS, a joint project with Russia that is expected to expand to other participating nations. If realized, ILRS would serve as a permanent scientific base on the moon, acting as an outpost for deeper space missions, including those to Mars. With the successful test of Lanyue, China is sending a clear message: they are not content to merely take part in lunar exploration, they intend to lead the new era of moon discovery. 2. NASA and the plan to light up the moon with nuclear power. While China focuses on its lunar lander, NASA is turning its attention to the question of energy, a critical factor for any long-term activity on the moon. One of its most notable projects is the plan to deploy a 100-kilowatt nuclear reactor on the lunar surface before 2030. The primary goal is to provide stable electricity for bases, research stations, scientific equipment, communication systems, and, most importantly, life support during the Moon's most extreme conditions, such as the lunar night, which lasts up to 14 Earth days, when solar panels become far less effective. Nuclear power technology in space is not new. The U.S. previously tested a small reactor under the Kilopower project in Nevada's desert, and the Soviet Union once launched satellites powered by nuclear energy. However, delivering such a system to the Moon, operating it in a near-vacuum environment with extreme temperature swings, from -173 degrees Celsius at night to +127 degrees Celsius during the day, and keeping it safe for human presence represents an enormous engineering challenge. Beyond the technical hurdles, the project also raises questions of international law. The 1967 Outer Space Treaty prohibits placing weapons of mass destruction on the Moon, but it does not outright ban the peaceful use of nuclear energy. Still, installing a reactor would require establishing restricted zones for safety, which could spark disputes over territorial control on the Moon. Some experts warn that this could mark the beginning of a land parceling of space, while supporters see it as a necessary step toward realizing off-Earth settlement projects. 3. LunaRecycle, turning trash into resources on the Moon. If Lanyue addresses the challenge of access, and NASA's nuclear reactor tackles the challenge of energy, then LunaRecycle targets another critical issue: resource sustainability. NASA has just entered the second phase of its LunaRecycle challenge, a competition seeking technologies capable of recycling plastics, foam, metals, and other waste generated during the operation of a lunar base. The main problem is cost. Sending just 1 kilogram of material from Earth to the Moon can cost tens of thousands of used, not to mention the strict payload limits of each launch. On-site recycling could drastically reduce the amount of material that needs to be transported from Earth, while also cutting down on waste and protecting the space environment, an increasingly urgent concern as space debris continues to accumulate rapidly. Proposed solutions include 3D printers that use recycled plastic to create new tools, technologies to extract metals from old spacecraft hulls for manufacturing components, or systems that compress and process foam into insulation material. The challenge is that every technology must operate autonomously, require minimal maintenance, and withstand the Moon's extreme radiation and temperature conditions. If successful, LunaRecycle could not only enable a self-sustaining lunar base, but also pave the way for mineral extraction stations and interplanetary missions at significantly lower costs. The three stories, Lanyue, the nuclear reactor, and LunaRecycle, may differ in their immediate goals, but they all point toward a shared vision: the Moon as humanity's second home. This is not merely a technological race, but the first step in shaping a new order beyond Earth. Whoever controls transportation, energy, and a sustainable supply chain on the Moon will hold a decisive advantage in the era of interplanetary exploration. If Apollo 11 in 1969 was simply about proving we can, then today's projects carry the meaning we will live, work, and thrive on another world. And perhaps the most fascinating part is that, while the major powers compete fiercely, every step they take, whether it's achieving a safe landing, providing stable power, or recycling waste, brings humanity closer to the dream of reaching beyond Earth forever. Don't forget to hit subscribe, like, and share this video to catch more exciting and up-to-date space news. Thank you.